Hi everybody. So in this video, I'm going to show you how to identify regions using inequalities. We're going to work through three examples, and in example one, we will have to shade a region that satisfies y is greater than x squared minus 4 and y is less than or equal to 3. So our first thing to know is that if it is less than or greater than, we use a dashed line. If it can be equal to, so less than or equal to, or greater than or equal to, we use a full line. So to show the inequality, y is greater than x squared minus 4, we can sketch this graph using the dashed line. We know this will have an intercept of negative 4, and the roots will be at positive 2 and negative 2. I found these two roots using the difference of two squares, so we've got x plus 2 and x minus 2. When we expand this out, we do get x squared minus 4. And because we're told y is greater than this, we're looking at the region above this dashed line. So now if we look at y is less than or equal to 3, well, this would be a horizontal line with a y-intercept of positive 3. And because it can be equal to it, it's a full line. And because we're told this is less than 3, we're going to look at the region below the line. So now we need to identify the overlapping regions. Now in this region, we are above the y equals a squared minus 4 line, and we're below the y equals 3 line. So this would be the region that satisfies both inequalities. Let's move on to example 2. Okay, so in this example, we've been asked to shade the region that satisfies these three inequalities. So I do the top one in red, the middle one in green, and the bottom one in blue. And the first thing we need to do is to sketch the graph of each equation. So to sketch y is equal to x squared minus 5x plus 6, we need to find the roots. And we can find these roots by factorizing. So y will equal x minus 2 and x minus 3. So our roots are when x equals 2 and x equals positive 3. And because it is not equal to this is going to be a dashed line. And we're told that y has to be greater than this, so we're looking at the region above this line. And then we're told that x has to be less than 3, but greater than or equal to positive 2. So this will be two vertical lines parallel to the y-axis. It'll be a dashed line at x equals 3, and a full line at x equals 2. And because the region that we're looking for is between these two lines, and our final equation is when y is less than 3. So we'll have a horizontal line parallel to the x-axis with an intercept of positive 3. And because it is less than 3, we're looking at below this line. And you can see that this region satisfies all three inequalities. So this is the region that we were asked to find. Okay, let's try one more example. Okay, so in our final example, we're asked to shade the region that satisfies these two quadratic inequalities. If we do the top one in red and the bottom one in blue, we need to begin by sketching the two quadratics. So if we say that y is equal to x squared minus 8x plus 16, we can find the roots by factorizing. So y will equal x minus 4 multiplied by itself, or squared. And because this is greater than, we'll use a dash line. And then for our second inequality, we've got y is equal to 15 plus 2x minus x squared. And again, we can factorize this, so we get y equals 5 minus x multiplied by x plus 3. So our solutions are when x equals 5 and x equals negative 3. So we'll say about here and about here. and we'll have an intercept of 15. And again, because this is not equal to, this will be another dashed line. And if we go back to the red inequality, we're told that y is greater than, this will be above the red line. And y is less than the blue inequality, this will be below the blue line. So the region enclosed between the two is what we've been asked to find. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.